Hello everyone. Welcome to my session. My name is Jing Li. You can just call me Jing. So I'm from IBM Platform Computing. So I'm currently working on several products of platform computing, including a platform cluster manager, platform HPC, platform MPI, and platform HPC cloud. It sounds like lots of different products, but all of them are HPC related. So that's why today I just stand here to have a discussion with you about the HPC solution stack on top of IBM Power System, OpenPOWER system. So talk a little bit about IBM Platform Computing. So I think if you come to my session, you should be very familiar with this company, Platform Computing, who has been working in the HPC industry for more than 20 years. But Platform Computing was acquired by IBM just around 3 years ago. So this acquisition makes the Platform Computing have a chance to spend a lot of effort on IBM Power platform. So before that, Platform Computing only focused on the x86 platform and x86 based HPC solutions. So that's why we can have this session to share with you. So today I will talk about this session, and so before I introduce this proposed architecture of the HPC stack, let's take a quick look at the business need for the HPC clusters. Actually, it's not only traditional HPC cluster. The requirement is actually common to all kinds of scale out and cloud-like clusters. So we have several. We identify several key requirements for the scaled-out clusters. So the first one is the requirement from the traditional HPC clusters. So this need is very straightforward. The system administrator and the user need to have basic provisioning and management requirements. So, but in today's HPC environment, the user would like to have the capacity, technical computing capacity to manage, to provide the service to multiple departments, multiple users, and multiple projects. This is so-called multi-tenancy. So it's very hot term in the cloud era today. So that's the second level needs for the scale-out clusters. So in this sessions, we can see lots of topics talking about the importance of data. So for the scale-out cluster, it's also important needs. So the infrastructure management system should also provide the data management capability, especially for the elastic storage management and monitoring. So also we have several additional needs identified for the scaled-out cluster infrastructure management. So we recently met a lot of customers, HPC customers. So today's customers, they all intend to manage their traditional HPC application together with their other business applications. So it's not only a pure bare metal cluster, but a combination with the other virtual machine-based clusters. It's just like a hybrid cloud environment. Also, the capacity overflow is also very important for today's scalable cluster, because today's workload is not static but dynamic. It's very possible the application needs more resource in the runtime. So but the user doesn't need to maintain a very big cluster to meet the peak requirement of their resource. So because we have the multi-tenant capability, so the user can easily burst their cluster to other clusters under same management. Moving forward, actually, the user can just maintain a very small cluster, and they can just rent a subcluster on top of a public cloud. So that means they can just easily burst their cluster to a public cloud. They don't need to pay for all the hardware and the maintenance cost in this situation. Also, big data cluster is more and more popular, so this is also a very general requirement for the scale-out and cloud infrastructure management solutions. So that's the needs we just identified. So here we come out a proposed architecture for a OpenPOWER based HPC stack. So you can from this chart you can see this stack is based on the IBM Power systems, including both the traditional Power big ending systems and the new introduced OpenPOWER systems. On top of that, we can see the hardware accelerators for the platform, including the infinite band and NVIDIA GPUs. We are talked a lot for these 2 days. So the key component of this solution stack is it's called IBM Platform Cluster Manager Advanced Edition. So that's the main product I'm currently working on. So this product has lots of significant features. So it have a very sophisticated infrastructure management base. So it's a basic requirement for the cluster management system. And we also have some innovative features on top of that. One is the cluster template designer. Here you can see we have a cluster template designer. It's a very innovative feature. So the user, the system administrator, only needs to do some very simple actions like the drag and drop operations on the GUI, so they can just design and deploy their customized clusters. So without this designer, the administrator needs to do a lot of command line work. It's very complicated and very easy to make mistakes. So, but we have this facilitator. This can help the user significantly. Also, we have a very well-designed monitoring and reporting framework. So I think for the enterprise level user, the monitoring and reporting is very interested by the administrator, by the users. So and all these functionalities are combined in a unified web-based interface. So the user only needs to interface with one portal. You can also build up another different stack by using some other products, maybe open source products. But it's very difficult to combine all these functions in one GUI. So we have all this designed in one unified web-based interface, and this interface is designed in a user behavior-driven model, so it's very friendly to the user. So let's take a little bit deeper for the components in this stack. So just like I just mentioned, the IBM Platform cluster manager is a key component in this solution stack. So, so the cluster manager is a powerful lifecycle management for the scale out cluster environments. It's not only includes the bare metal cluster, but also it supports the virtual machine clusters. So this has been implemented by the integration with OpenStack. And the key capabilities I just mentioned, so I will not repeat that again here. But for the user, he can get a faster time to cluster readiness, and he can have a unified interface for management and monitoring, and it can increase the administrator's productivity significantly, and it's a single infrastructure to supporting multiple business needs. So in the wrong side, you can right side of this chart, you can see some screenshots of this product. So the first one is a dashboard view. So from this view, you can see an overview of the cluster you are managing. And the second one is the innovative feature. We call that cluster template designer. So you can see more details for these two functions in the coming slides. So on this slide, you can see a single interface for management and monitoring of multiple clusters. So this one, is just a overall status of the cluster. You can see the usage of the CPU, memory, even the power consumption information. Also, on the left side, you can see all the other management functions are on the same GUI. So we also provide a Rackview for the cluster you are managing. So from this view, you can it's just like the administrator. It's just like you just stand in front of your clusters. So, but the user doesn't need to go to the machine room. He can just look at the status of each node of your cluster from the GUI, and you can just click on on each node to see more detailed information of that node. Also, you can start a console of the rack from this GUI. So it's very, very convenient for the system administrator. So this one is this chart shows the cluster template designer. So just like I just mentioned, you can see we have lots of designed script templates in the left side of this the GUI, and in the right side of GUI, we can just the user only needs to drag the script template to the right side. So, for example, we have tiers and layers terms in this tool. So, for example, if you want to design your GPFS cluster, you only need to drag the related script from the left side to this layer. That means the scripts you want to execute on top of on that particular node, including the pre-script and post-script. Also, if there are different categories of nodes in your cluster, for example, you may want to configure a Hadoop cluster. You may have a date node and a name node. So you can design different type of nodes in different tiers. So that's very easy operations for the user. So the user only needs to do some drag and drop options in this GUI. Also, for some very popular cluster, we already have some out-of-the-box cluster templates embedded in the system. So you don't need to you even don't need to rewrite the script for the cluster. So that's from the cluster point of view. If you want to do a more precisely configuration to a particular node, you can use the provisioning templates to configure one node very precisely. So you can see from this GUI, you can configure the name of the node, the image profile for the OS image you want to deploy on that node, and network profile, hardware profile, and all kinds of configurations for that node. So all these profiles can be customized by the user in the cluster manager as well. So the hardware management is the very basic function of this cluster manager, and we also have a very sophisticated monitoring function embedded in the system. So in the previous slide, I just showed a overview status of the cluster. In this screenshot, you can see the user can figure out the very detailed information for a particular node. So alert alert. So we have a very good alert framework that is based on the monitoring and monitoring functionality. So the user can customize their alert mechanism. Also, alert can trigger automated predefined actions. For example, you can just send an email when something happens, or send a text message to the system administrator. Also, we are still enhancing the alert function in our product. So we will have event-based alert that will be more efficient and more real-time. So also we can see resource reporting from the cluster manager. It not only includes the cluster availability and cluster performance and usage information, but it also shows the free application licenses of the application. It's a very attractive feature. So from that architecture, we just introduced the infrastructure management product for in the HPC solution stack. I just introduced in the third slide in my presentation. So, but we still need to have other components to build up a complete HPC solution stack. So, including the application runtime and development functionalities. So IBM has a very mature product named PE runtime and developer time environment for that. So it has a long history to support IBM Power system. Also for the workload management, so platform computing has a very famous workload scheduler named LSF. It's the most popular software for the workload management. So also for the data management, so IBM has Spectrum Scale, which is built based on the GPFS technologies, and our PCM cluster manager product has a very good support for the Spectrum Scale. And for the application environment, we have Platform Application Center and the Platform Process Manager to well manage your applications running on your HPC solution stack. And also, you can use the Platform Process Manager to manage the flow of your applications. So the most important thing here is all these components are IBM-owned products. So we have the we have certified support to the IBM OpenPOWER system. So because OpenPOWER has been just introduced not in a very long time, but because we are all in IBM, so we have we are very fast in the support to the OpenPOWER platform. So the subsequent slides are about the more details for the components in the complete solution stack. So this one is the IBM PE Parallel Environment. So this is a high-performance execution environment to help the user can take the full advantage of the scalable computing resource. It has a very good reputation to support IBM Power platform. So you can see it's very important here. So from the Ubuntu 14.04.01, it has the little ending NV non-virtualized version supported. That means it can well support OpenPOWER. So the LSF I just introduced is a platform key product actually. It has a history of more than 20 years, so it's very mature product. So it can help, it's most complete, most powerful, and most scalable, and help the user can have the best TCO. So it's also OpenPOWER supported. So IBM Platform Application Center, so it helps the user can increase the productivity to work with a GUI, a browser-based GUI. So it also supports the 2D and 3D remote visualization. Also, it's enabled access via mobile devices with web services. So it's a very attractive function. So this is the IBM Platform Process Manager. So it's a very interesting product. So you can see if you don't have such kind of product, you may need to manage your application execution flow manually. So that means the user needs to wait for the finish of last job and start up a new job manually. But with this products, you can just manage your workload flow just like programming. You know, you can do some flow. You can use the flow editor to manage the execution flow of your different applications. It's very intuitive drag and drop interface. And also you can use the Platform Process Manager, Flow Manager to see the execution status of your applications. So all these functionalities has been designed in a very well-designed GUI. So given that you can build up your personal HPC solution stack, here we have a reference architecture. So in this architecture, you can see other options. So you can use a different solution stack as you wish, but just like I mentioned, our solution stack has been fully verified and certified. So I think it's the best solution at this moment. You don't need to think about lots of things. You just use all these components together, and all of them has been proved to be able to run in OpenPOWER successfully and with high performance and high reliability. Okay. So I just attached several links for you. If you want to see more detailed information about our products, you can click these links, and also you can talk to me after my session, also you can reach our product manager, Maddie, and the product marketing manager, Gabo. They are located in Toronto lab. So once you have any question, you can just talk to me and them. Okay. So that's my session. So any questions?